Here in Chapter 7, we will be learning the different methods of solving systems of linear equations. Before we look at the first method, we will first learn how to write a system of linear equations in matrix form. Any system of linear equations can be written as a matrix called the augmented matrix by simply writing the coefficients and constants that appear in the equation. Example, if you have this system of linear equations with three unknowns x, y, and z, the augmented matrix is given by this. The first column contains the coefficients of x, the second column contains the coefficients of y, the third column contains the coefficients of z, and the last column contains the constants. So for the first equation, x plus 2y minus 4z equal to 5, this represents the first row of the augmented matrix with entries 1, 2, negative 4, and 5. For the second equation, we have 2, 1, negative 6, and 8. For the last equation, we have the coefficients 4, negative 1, negative 12, and the constant 13. Another illustration is this. We have three equations and three unknowns. The augmented matrix is given by this matrix. For the first equation, we have 1, 2, negative 4, 5. For the second equation, we have 0, negative 3, 2, and negative 2. For the last equation, we have 0, 0, negative 2, and negative 1. So now we will be learning how to solve a given system of linear equations by Gaussian elimination. First, we will understand a matrix that is in row echelon form. So a matrix is said to be in REF or row echelon form if the following conditions are satisfied. First, the first non-zero number in each row is 1, and that is called the leading entry. Next is the leading entry in each row is to the right of the leading entry in the row immediately above it. And lastly, all rows consisting entirely of zeros are at the bottom of the matrix. Here is an illustration of a matrix in row echelon form or REF. The leading entry for every row is 1. The leading entry of a row is to the right of the leading entry of the row immediately above it.